Page 62, we're into exponents. Exponents are really actually quite fun. They just make a lot of sense. 6 times 6 is 36, therefore 6 squared is 36. The square root of 36 is 6. And I would like you to complete the following. The first 3 are just square roots, this expand form. 5 times 5 equals, and then 64 square root is 8 times 8, and you can finish the rest of them off, and we'll see you on the next page. Great. Page 63, we're continuing on with exponents, and what we're doing on this page is we're taking our exponent, for example, 3 to the 5th, and we're expanding it to show you that it is actually 3 times 3 times 3 times 3 times 3, giving you a product of 243. So go ahead and write in the expanded form the exponents in the next 4 problems, and write the product of the exponents in the last 2 problems. 64. We're moving on to exponent vocabulary. So the 2 distinct parts are the base and the power. In this example, 2 to the 3rd, the 2 is the base is the 2, and the power is the 3. And we would read this as 2 to the 3rd power. Okay? So answer the following questions. What is the base? What is the power? What is the product? Answer. And Rachel thinks the answer is 9. So can you tell me why where she went wrong? Right? Think about those questions. Great. Page 65, we're continuing on with exponents and the exponent rules, and we'll take each of them in turn like we did with properties. So the first one is the product of powers, and this says that if you take your base, your 2, to the 3rd times 2 to the 2nd, that the exponents are added together. So if it is a multiplication with the same base, you add the exponents. The expanded form of that you can see is 2 times 2 times 2 times 2 times 2, giving you 32. Go ahead and finish, you try them, the next 3 problems. Page 66. So negative exponents, like negative numbers, have an easy way to evaluate them. In the negative exponent example, what you do is you take the negative exponent, 2 to the negative 2, rewrite it as a reciprocal, and change the negative sign to a positive sign. So the negative 2 just lets you know that it wants to be in the denominator. Okay? Another example is 3 to the negative 3. Again, you take its reciprocal, 1 over 3, in this case negative 3, change the negative to a positive, leaving you with 1/27. You can see that. So rewrite as a fraction and simplify the next few problems. 67, more exponents. We're going to review a few more rules here on this page. The first one, quotient of powers example. Quotient of powers. When we divide numbers of the same base with exponents, we subtract the exponents. It is the opposite of multiplying exponents. When multiplying, we add them. When dividing, we subtract them. There's kind of a simple way of remembering this. So in this case, 4 to the 4th divided by 4 to the 3rd gives you 4 to the 4 minus 3, which is 4 to the 1st power. First powers are always the same number, 4, because there's only one 4, right? So the exponents 4 minus 3 will equal 1. As you can see, they both have the same base, which is 4, so the exponents can be subtracted. Remember that the symbol right here, the / symbol, is just another way to show divided by. Anything to the power of 0, however, is 1. So any number, 100 and million to the 0 power is 1. And this is a really perfect test question, just to let you know. Okay? Go ahead and simplify the next few problems, and we'll go on to the next page, 68. We've got the power rule, continuing on with exponents. Power rule 1, example. So you've got 2 to the 5th to the 3rd, right? So now we have 2 to, one way to think about this problem is just like a regular exponent problem. We've got 2 to the 3rd, which is 2 times 2 times 2. However, it's 2 to the 5th. So it's going to be 2 to the 5th times 2 to the 5th times 2 to the 5th. The expanding of the power rule allows you to use the product of powers rule where the exponents are added together equally. So again, this is multiplication, so we're adding exponents, that exact thing we just went through. So we now have 2 to the 15th. We've got 5 plus 5 plus 5, or 5 times 3. Go ahead and leave your answers here in the exponent form of the power rule number 1. 69, we're going on to advanced exponents. You can do more with exponents and fractions. If the exponent is a fraction, like 2/3, what we do is we put the numerator 2 inside the root, raising, in our example, 4 to the 2nd power. As you can see here, 4 to the 2nd power inside the root. And then the denominator 3 we use as its root, or cubed root in this case, or you could also call it radical 3. So it's cube root of 4 to the 2nd power, right? Write these in the same form as above. There's only 3 of them, so we'll move on. Page 70. The key here on this page is that if the exponent is a fraction, then that fraction denominator, in the first one, 1/2, is actually the root. So we've got square root of 2 to the 1, which is 2. So the square root of 2, which doesn't work out very evenly, but that's we'll talk about more complex numbers later on. Go ahead and rewrite the following numbers, noting that the fractions have the root in them. So the 2, the 3, the 4. All right? Page 71. We're almost done with exponents. So we've got a little more to do with advanced exponents. When evaluating, for example, a square root of a number, the very simple way of explaining this is we are trying to find a number that when multiplied by itself, or in fact squared, equals the number inside the root sign. So as an example, square root of 4 is 2, because 2 times 2, or 2 squared, equals 4. The cubed root of x looks like the cube root of x. And the same thing, when you're taking the cube root of 8, 2 times 2 times 2, 3 of them, equals 8. So 2 to the 3rd, or 2 cubed, is 8. All right? So this is an explanation. Some of the numbers will get difficult and calculators are necessary, but for the context of this book, we don't need a calculator. Page 72, cubed roots. The cubed root, for example, of 27 is 3. And there's a cube root table right here, and the table goes from 1 to 9 cubed roots. That'll help you answer the questions in the expanded explanation here. So what you want to do is 2, for example, a cube root of 8. 2 because 2 to the 3rd, 2 times 2 times 2, equals 8. Okay? All right. Go ahead and finish this and we'll come back and finish this out. 73 and 74, exponent review, last 2 pages of chapter 2. Now in page 73 is just a powers exponent review. Go ahead and finish that. And on to page 74, something a little different, is called substitution. We're going to be using that a lot in algebra. So substitution here is where you've got your variable and you have a value that's attached to that variable. So anytime it comes up in an equation like the problems on this page on 74, you will substitute, for example, minus 15 in for the variable x, and then so forth, minus 21 and 3 for y and z respectively. So we'll see you on chapter 3. Congratulations, and subscribe, ring the bell, and buy a book. Okay, my name is Susan. I'll see you on